Good morning, ladies and gentlemen. Welcome to non-right angle trig, starting off with the sine rule. So quick recap of what we've done in the last couple of years is looking at labeling conventions for non-right angle triangles. We no longer have a hypotenuse, so it doesn't make sense to label one side H, or in the case of Pythagoras, label it C. Here we label the points, or the vertices of the triangle, A, B, and C, and it doesn't matter which order they're in, and very simply, the side directly opposite from them becomes little a. So A faces little a, point B faces side little b, and C to C. It's important that all non-right angle trig corrections start off by you labeling the triangle, because then it relies on you putting those into a formula, those values into a formula to come up with the solution. Alright, the sine rule. Now I'm not going to go through the proof of it, but the logic is quite simple. You see here how A is the largest angle. That also means that A is the largest side. And C is the smallest angle facing the smallest side. Largest angle always faces the largest side, etc. So what we can do is we can say essentially that big angle over big side, a big number divided by a big number gets you a regular size number, or we'll get you something approximately equal to, small angle over small side. What we're essentially looking for is pairs. A large pair and a smaller pair that will then, if we make the ratios, equal each other. Or the ratios will approximately equal each other. That doesn't work exactly, it requires the use of sine to work, and that's what leads us to our actual rule. The rule can be stated two different ways. You would only ever use two parts of it at the same time. So we might say that A over sine A equals B over sine B. Or we may say that A over sine A equals C over sine C. And it's this form of the equation that I highlighted here that's typically used for finding sides. This form is used for finding angles. However, for our purposes, both work for both. I would typically just use this one, it's easier to remember. I find it easier to remember. We use the sine rule when there are two sides and the angle opposite one of those sides is given, or when we have two angles on one side. Sine rule is the most commonly used rule. Basically, my advice is try to use the sine rule, and if it doesn't work, or you can't set up the equation, then go with cosine rule. Alright, a couple of examples. Here, label the sides. A, B, C for the points, little a, little b, little c. Then we're looking for pairs that are opposite each other. Here's a pair we know, as in we know both sides of the pair, and a pair we half know. Alright, so then let's look at the A and the C pair. So the formula we would use is A over sine A equals C over sine C. And as long as we know three of those letters, we can solve for the fourth. So in our case, it is 7 over sine 60 equals x over sine 80. Now note, from here, this point, you can use CAS. Alright. And at this stage, I'd like to introduce a slightly new version of solve. So in the past, we've always just used solve. Say, that one. But there's another option. Menu 3. Instead of 1, which is ordinary solve, we can go numeric solve, which just looks like nsolve. Now the purpose of nsolve is it provides the first positive answer, numeric answer to the equation. This equation here will only have one answer, so it'll get us the answer. However, later down, where we do angle, if we're finding an angle, for reasons that are beyond the further course, trig has an infinite number of correct answers. So here, we would have to use nsolve to get the first correct answer. Right. So nsolve works exactly the same as the other one, as the previous one. We would do 7 over sine 60 equals A over sine, and the angle is 80, or x over sine 80. X over sine 80 comma x. 7.96. Alright. However, we can't, it's probably best we don't just write 7.96 in our notes, because quite often, especially in paper 1, they don't just ask you to find the side. They'll give you a question like this, where they ask you to find an angle, and they don't give you options of angles for an answer. What they do is they give you a whole series of different equations and say, well, which one is the right one? So, what we have to do is to be able to know the working from the highlighted stage here to the end line. And the working looks like this. It's quite easy. We would multiply both sides by sine 80. So 7 over sine 60 equals, multiplied by sine 80. Got to remember the actual working step. Equals x. The other way you may see this is 7 sine 80 over sine 60 equals x. And that would be the more elegant way of writing it. Alright, so there's that one. 2 more examples quickly. Up there was finding sides, now finding angles. Finding angles. Once again, we want to label sides. A, B, C, A, B, C. Look for opposite pairs. This is a pair we know. This is a pair we half know, which is good. So if we get that set up, we can then use it to solve. We would say we're using the B and the A side, so B over sine B equals A over sine A. Alright, and then sub in, so B over 3.6 rather, over sine B is equal to 5.1 over sine of 100. Alright, now here is where we have to use a little algebra or n-solve. So note at this stage here, you can just use CAS with n-solve if you want the answer. However, if you're going to work this out algebraically, then that's fine. What happens is we essentially cross multiply. So 3.6 sine 100 equals 5.1 sine B. Divide both sides by 5.1, so 3.6 sine 100 over 5.1 equals sine B. Now that's strictly speaking not B by itself yet, therefore B is equal to 3.6. B is equal to the inverse sine of 3.6 sine 100 over 5.1. And I'll leave you to put that in your calculator. Alright, now, the reason we want to show all the working steps is because sometimes there's a question like this. So this is a past exam question. In the triangle ABC, sine alpha equals 0.8, sine beta is equal to. Note the key here is they're not asking us to find beta. They're asking us to find sine beta. So if we look at this, we have half a pair and half a pair, which at the start doesn't look very promising. But let's try and set it up anyway, because we're talking about sines here. So we would say A over sine A equals B over sine B. In our case, we would have A as side 20 over sine alpha equals 15 over, now instead of sine alpha, I should remember that sine alpha, we've been told, is 0.8. So I'm going to replace that sine alpha with 0.8 over sine beta. And now it's a matter of trying to find what sine beta is. So we do our algebraic steps again. 20 sine beta equals 15 times 0.8. Sine beta equals 15 times 0.8 over 20, which is 0.6. Now note, we don't have to go to the extra step of solving for beta. We just have to say that sine beta is equal to 0.6, and that's our answer. Alright, thank you very much.